Alright guys, are you ready for it? We're going to cover lessons 8, 6, 7, 8, and 8.9. So we're going to be factoring trinomials. So I'm going to give you a one-stop shop for how to do it. Oops, if I could spell better would be good. Trinomials. And I'm going to give you different examples that will cover from each of these lessons, okay? So you gotta trust me on this one, okay? We're going to use what we learned in 8.5, the factoring by grouping, as part of what we're going to do, but we're also going to put it in combination with a game, okay? And it's just kind of a streamlined way to come up with values that match our situation. So first is the game we're going to play is called the Prada Sum Game. And it has to do with the numbers that are in your trinomial, okay? And then the second thing we will do is do factoring by grouping, or factor by grouping. Let's just do it that way. Say factor by grouping. Okay, so let me explain the game. Let's go ahead and talk about the kind of generic equations that you're going to be seeing. We have x squared plus bx plus c, or ax squared plus bx plus c. Now those signs can change, and we've got a stipulation that b and c are numbers except for 0. So you can't have 0 for b or c in order for us to use this strategy. Okay, so first things first. We talked about in the last set of notes that you must make sure that you pull out any common factors. That's it. No common factors. So you got to pull out the GCMF. Start with that always. So I'm going to put that here before we get to the game. So I'm going to do a nice big red. Always factor out the GCMF. Remember, it can be numbers and it could be variables if one is present. Not all of your problems will have a GCMF, and sometimes I go so darn fast that I don't even look for it, which is naughty on my part, okay? All right, so let's go ahead and talk about the product sum game. I used to call this the Lattice Method, and I'll tell you why in just a second. So I'm going to kind of, on the right side, give you a demonstration, and then the left side would be explaining in words. So here's our beginning trinomial. So I have x squared plus 4x plus 3. Okay. So step 1. We're going to multiply. Oh, I guess I should name these because people, I don't think we've done that yet. That could be my problem. Okay, so before I begin that, I am going to label each of the parts. The guy that has the square term is called the quadratic term. The guy that just has the plain old x, he's called the linear term. Okay, because, you know, if we just have an x, we can draw, and then we get a line. And then the c is the constant, which that should be obvious. Now, what's weird about the constant is sometimes the constant has a variable, so watch out for that. So here we go. So step 1. we're going to multiply the quadratic coefficient by the C value. I'm going to call it C value because, again, it could be more than just a constant. So this is called the product. Okay, so in our particular example, the quadratic coefficient has a 1. So we're going to take that and multiply it by the constant, the 3, and we get a product of 3. Okay. Then we're going to identify the linear coefficient and this number is going to play the role of the sum. Okay, so in our particular problem, the linear coefficient is the 4 because it's attached to the x. Okay. Next, we're going to create what I call a lattice. People call it the big box. They call it the x, whatever you want to call it. So a lattice is just basically, I have a fencing. Had a fencing. Do I still have some? I can't remember now. In the backyard, which looks like a series of X's. So you has some openings, so plants can kind of go through it. We're going to call it a lattice or an X. Okay, so it looks like this. Bink, bink. Now we have to place things. So we're going to place the product value, the one we multiplied to get, that's why it's called the product value, at the top. And the sum, oops, at the bottom. So for us, it would look like this. The product was 3, that's going to go at the top, and the sum, the linear coefficient, is the 4, it's going to go at the bottom. Now, I think this is where we're going to shift over to here. Let's see, maybe I could go a little closer. Let's go a little closer. So next we're going to play the game. So think of two factors, so numbers that multiply together, that multiply to make the product number and, oops, sorry, I'm supposed to write and, I'm giving away my secrets, and add to give the sum number. Okay, so I'm going to think about that. Oh, and by the way, I should put some signs. We had a positive times a positive, and when we added, we had positives. So what are two numbers that multiply to give me 3, but add to give me 4? Multiply to give me 3. The only two numbers I can think of is 1 and 4. Add to give me 4. So it would have to be a positive 1 and a positive 3. Okay? So we're going to, and I kind of did it already, we're going to place these factors on the sides of the x, or lattice. And again, include signs. Now I'm giving you the easiest case right now as we kind of go through this practice. Okay? So, what we're poised to do now is to use factoring by grouping. So that's going to be our next addition. Oops, that's the wrong color. Let's do... This is where factor by grouping comes in. So what we're going to do is we're going to turn the trinomial, our x squared plus 4x plus 3, into a 4-term polynomial. So turn the trinomial into a 4-term polynomial by splitting the middle term into 2 terms using the factors from the game. Okay, so I'm going to go back to the original guy. Let's just do black. So underneath here we've got x squared, and then it's going to end with plus 3. But then what I need to remember is my middle term was 4x. So we're going to take those two terms and we're going to put plus x plus 3x. Why are there x's there? Because they have to add up to equal 4x. Okay? And then factor by grouping. Okay, so what we're going to do is we're going to, oops, let's see, these two have an x in common, and these two have a positive 3 in common. So this might get a little bit messy with my work, but bear with me. So we have x times the quantity, and when we factor that out, x squared divided by x is x, plus x divided by x is 1. And then we're going to pull out a positive 3. And 3x divided by 3 is x, plus 3 divided by 3 is 1. So I'm going to continue over here. Our magic happens. Notice the binomial x plus 1 shows up, so we're going to factor that guy out. And then the second binomial is made up of x plus 3, the coefficients. Now, if I multiply this out, I would get x squared plus 3x plus x plus 3, which would add up to give me x squared plus 4x plus 3. So it does work. Okay, so I know this is weird, but we're going to do this. So I'm going to give you some examples from each of those lessons and see how we deal with them. So this is going to be, unfortunately, a long video because we have a lot of practice. And we'll be practicing in class as well. So the directions are just going to say factor. Okay, now some of you may figure out a different way of solving this in terms of just looking at the factors, and you may see some patterns that exist, but they don't work for every single type of problem. Okay, so this strategy will work for all of them. So let's do one. We need to bring in some signs. So let's do it this way. We've already done one with positives, all positives. So let's do x squared minus 8x plus 12. Okay, so we're going to play the game. And we're going to go ahead and find the product. So that's going to be positive 12. And then we're going to grab the linear coefficient, so that's going to go here. So now I need to think of two factors that when I multiply them, I get positive 12, but when I add them, I get negative 8. So here's where logic comes in. I cannot get a positive answer if I have one positive and one negative number. So both of my numbers are going to have to be negative. Okay. So what times what gives me 12? So I have 3 and 4, 1 and 12, and I have 2 and 6. So then if I add them, I would get a 7. That doesn't match. I would get a 13. That doesn't match. I would get 8. So these are going to be the two terms I use. So I have already put my signs in. All right, so now I'm ready to split the middle term into from 8x to negative 2x minus 6x, and then plus 12. Then we're going to factor by grouping. So these have an x in common. Now here's where it gets a little tricky. You got to pull that negative out. So they have a negative and a 6 in common. So this gives me x times, let's see, x squared divided by x is x, minus 2x divided by x is 2. And then I have to pull out the negative 6. And negative 6x divided by negative 6 is x. 12 divided by negative 6 is negative 2. And there we get what we want. So we get x squared minus 2 times the quantity x minus 6. So notice what happens now that we have negatives and where the negatives are located. So let's try another one. And this time, let me box this. Let's put the negative at the end. So x squared plus 2x minus 15. All right. So we got our x. We're going to multiply for our product number. 1 times negative 15 is negative 15. That goes on top. And then we're going to grab the linear coefficient, which is a positive 2. Now, the only way you can get a product that's negative is if one of the numbers is positive and the other number is negative. So what I do is I pay attention to the sign of my sum number. It's positive, so I'm going to put the positive one on the left and negative on the right. So what happens now is that I'm not going to be adding the factors to get the negative 15. Because of the sign difference, I'm going to have to subtract the numbers. So what times what equals 15? let's see. We've got 1 and 15, and we've got 3 and 5. Now remember, I need it to be positive is the bigger number. So positive would go with the 15, positive would go with the 5, negative on the 1, negative on the 3. So if I add these together, 15 and negative 1, I get 14. That's not going to work. And then 5 plus negative 3 is going to give me positive 2. So that's what I need. So these are going to be the factors that I'm going to use. So a lot of logic goes on with these problems. Okay, so what does it look like? Same as the last one, but just sign differences. So we have x squared, and then I have, and what I like to do is put the negative number first, and I'll tell you why in a second. If that's an ability, last problem, they both were negative, so I didn't have an option. So I had negative 3x plus 5x, and then minus 15. Okay, so now I'm going to go ahead and factor by grouping. And these two have an x in common. And this is why I do this. If I put the negative in the second spot and the positive in the third spot, I'm not pulling out a negative number. And then 5 and 15 have a 5 in common. So this is going to factor into x times the quantity, x minus 3 plus 5 times the quantity, x minus 3. So, there we go. We got our magic. So we have x minus 3 times the quantity, x plus 5. So signs are going to be essentially important for us to pay attention to. And again, you can always multiply out to double check that you got your signs in the right spot. Okay? All right. So let's talk about what if we have a problem like, because right now all of our coefficients of the quadratic term have been 1. Now let's change that. Let's make it not 1. So 7x squared plus 29x plus 4. Okay, so now we're going to get a substantially larger product number. So 7 times 4 is positive 28. Then we're going to grab the linear coefficient, which is a positive 29. And what are factors of 28 that add to give me 29? Well, we're only going to consider one case, right? Because 1 plus 28 will give me 29. None of the others will give me that. So we have positive 1 and a positive 29. And it actually doesn't matter. Sorry, 28. It does not matter the order of these factors that you put into the x, okay? So now we'll do factoring by grouping. Well, we'll split the middle term first and then factor by grouping. And so we have an x and 28x. And then round it up at plus 4. So the first two have an x in common, and the second two have a positive 4 in common. So I'm always grabbing this sign, okay? And then that's going to give us an x times the quantity, 7x plus 1, and then we're going to pull out the positive 4, and we get times the quantity, 7x plus 1. So our magic occurs. We get 7x plus 1 times the quantity, x plus 4. Okay, and there you go. Oh, I forgot to box up this answer. And let's Let's do another one. Let's put in a negative. Where haven't we had a negative? Let's do it in all spots. Okay. Now, is it possible to get something that's not factorable this way? And the answer would be yes. And the reason why it wouldn't be factorable this way is because we're getting integer values here, but it is possible to get fractional values. It is possible to get irrational values. Those are square roots of numbers that aren't perfect squares. All right, so on this guy, the product number is -2. The sum number is, if I just see a negative, it's a -1. So notice that my signs are different. So we're going to pick two numbers that when I multiply them, they give me -2, but when I add them, they give me -1. So that means one is a positive and one is a negative. So the only two factors of 2 are 1 and 2. So we need to have the bigger number be negative. Okay, and so that's going to be working for us on this one. So let's split the middle term. 2n squared, and then we're going to have, and again, I'm going to try to put the negative in the second spot, -2n, and the positive in the third spot. That cuts down on that particular sign issue. So we're going to go ahead and factor by grouping. So these two, they have a 2 and an n in common. And then the other two, they only have a positive 1 in common. So if you can't see a number in common, it's always going to be 1. Could be positive or negative. So this gives me 2n times the quantity. Let's see, so 2n squared divided by 2n is n, minus 2n divided by 2n is 1. And then we're going to pull out a positive 1. So I'm going to actually write it because it's going to play a role in one of the binomials. And then I have n minus 1. So the magic did occur. So I get n minus 1 times the quantity, 2n plus 1. Okay? So let's see what else we can do. Let's give you some special ones. All right. What if, and notice so far we haven't had any GCMFs. I've kind of glossed over that, and I apologize for that. Let's try this one. Okay, now this one's kind of weird. We don't have any middle term. So let's see how that's going to work out in the game. Well, it's always first and last is the product number. So we're going to multiply 16 times -9. So I don't remember that. So I'm going to do it to the side. So that's 54. So it's 144. So it's -144. Oops, let me change that color. And there is no linear coefficient, so that's going to give me a 0. So what I need to do is figure out factors of -144 that add up to equal 0. So here's what's going to happen. This is called, remember the answer you see, that binomial C is called a binomial square, or a difference of squares, because the first term, 16n squared, is only made up of perfect squares. The back term, 9a squared, is also only made up of perfect squares, and there's a subtraction or difference sign. So what I'm going to get is always going to be a perfect square as my product number. So what times what equals 144? 12 and -12. Okay, so we're going to split the middle term. So we're going to split 0 into -12 12. Now here's the deal. When I have two variables, their square roots show up in the middle terms. And then we have plus, I didn't put that in there, let me just do that, okay. And then we've got plus 12na, and then minus 9n squared. So look what happens. This is so cool. So these two, let's see, they have a 4 and an n that goes into both of them. And the other two, let's see, they have a 3 and an n. Oh, no, this is supposed to be an a. Sorry, I wrote that wrong. Let's get that fixed. I was going to say that didn't make sense. So that's going to be an a that comes out. Okay? So let's see what happens. Let's see if the magic happens. Let's see if I've done it right. So I get 4n times the quantity. See, 16 divided by 4 is 4, n squared divided by n is n, minus 12 divided by 4 is 3, and a divided by n is a. And then we have a plus 3a. And then 12 divided by 3 is 4, and a divided by a is n, minus 9 divided by 3 is 3, a squared divided by a is a. And our magic occurs. So we get 4n minus 3a, and then that gives us 4n plus 3a. Oops, sorry, that's supposed to be 1. Okay, now notice you have exactly the same terms in the front and in the back of both binomials. The only thing that's different is you have one that's a sum and one that's a difference. Okay? I've been bailing on my box in here. Alright, so that's what I do with the difference of squares. Oh, let me show you another one. Now, when you factor, you always have to check your binomials to see if you can factor more. So let me give you an example when that happens. So the sum number is going to be negative 16. 16 is a perfect square, right? Your sum number is absent, so that means it's 0. So what times itself gives me 16? It's going to be 4 times 4, but we're going to have one that's a positive and one that's a negative, so I'm going to put the negative in front and the positive in the back. Now this one only contains one variable. So when I split the middle term, remember, is the non-existent one. We're going to have a negative 4n, or 4b, excuse me. And then plus 4b. And then minus 16. So we're going to go ahead and factor by grouping. These two have a b in common. Oh, you know what? That's right. That's not going to work, because then that would give me a b cubed. So remember, it's going to be, factoring is like cutting in half. So I almost blew that. Sorry, guys. Their exponents are going to be half of the original exponent. Exponent of middle terms half of quad terms exponent. Okay, so we're going to actually factor out a b squared. And then on the second grouping, let's see, we're going to take out a positive 4. Okay. So that's going to give us b squared times the quantity. B to the 4th divided by b squared is b squared, minus 4b squared divided by b squared is 4, and then we have plus 4 4b squared divided by 4 is b squared, minus 16 divided by 4 is 4. So we get our miracle, and we get b squared minus 4 times the quantity b squared plus 4. Now, what we need to recognize is that b squared minus 4 is still, it's the difference of squares, which means it's factorable still. So it's like we play the game a second time, where we have the product is negative 4 and the sum is 0. So we're going to have a positive 2 and a negative 2. So just this guy here, not the other guy. The other guy's a sum. We can't do anything with sums. So he's going to become b squared, and half of 2 is 1. And we're going to have minus 2b plus 2b minus 4. And we're still going to have the b squared plus 4. So we factor by grouping. These two have a b in common. These two have a positive 2 in common. So we get b times the quantity b minus 2. And we have plus 2 times the quantity b minus 2. And then that's still being multiplied by b squared plus 4, the sum of squares. I cannot factor. So the common factor is the b minus 2. That puts the coefficients b plus 2, and we still have b squared plus 4. That is the answer. I know your head's probably spinning now, and we've had a lot of examples, so I will forewarn you to take breaks. And then I got one more to show you. I know, you're like, stop. Just one more. So this was something else we had mentioned in class. See, geez, I can't even remember what number we're on. 7. Lucky 7. So let's say we have something that looks like this. 9x squared minus 48x plus 64. So the problem is our numbers are getting quite large. And I'm looking for, I was hoping there's going to be a GCMF, but there isn't. We haven't had any on these. So our product number is going to be, again, the 9 times the 64, which I don't know, so I'm going to do it off to the side. So you get 36, 54, 55, 56, 57, so 576. So it's a positive 576. And then we're going to grab this guy, negative 48. Now, 576, man, I don't know that. So let me think about what that's all about. So if we start with the two factors that we were given, 9 and 64. Now, because of the signs, we have a positive product, which means both signs would have to be negative. So we'll know that both of our numbers will get a negative on them. Now, I am going to add these, and that would give me a total of 73. So 64 plus 9 is 73. So I know that's not the right combination. So what I'm going to do is I'm going to play with factors. And I'm going to think of maybe breaking this into 4 and 16. And let's see, maybe I could create a factors of 36 and 16. So I'm just playing around now. And if I add, I get 40, I get 52. Ooh, that's super close. Okay. Let's see. So this is going to be 4 times 9. This is 4 times 4. So that doesn't seem to help. Maybe if I could do like, that would take me back to what I just had. So let's try 2 and 8. So let's see. So I could have 32. That's going to be 8 times the 4, and the 9 times the 2 is 18. So let's see if I add those, that gives me 50. Okay, that's pretty close. Huh. But I'm still not getting. So let me try something else. Let's try 12 and 3. So you just have to kind of play around. So let's see. How about 12 times 2 and 3 times 8? Oh, There it is. That's it. So what I've got is actually 576 is a perfect square. Now notice what happens when I substitute this in. This pattern showed up before. So when we have super large numbers, it gets harder. So there are some patterns that if you can memorize them, it makes math a lot easier, but sometimes they're challenging. So they both have a 3 and an x in common. And the second two have a negative, let's see, 8? Yeah, an 8 in common. All right, so let's see what that gives us. So the 3x, we're going to get a 3x minus 8. And then when I pull out the negative 8, that's going to make it 3x positive, right? And then negative 8. And the miracle happens. Now, wait till you see the second miracle. You end up getting the same binomial twice. So we don't write it twice, we write it once and use an exponent. So this guy is called the trinomial square. So trinomial squares have a pattern that if you recognize it's a trinomial square, and that's kind of tricky to do, notice, where do you think 3x came from, and where do you think 8 came from? I want you to think about that, and we'll talk about it more in class. All right, I'm done. I know this has been incredibly long. All right, talk to you soon. Bye now.